Hey guys, we're back. We're going to ask that you please open up your lab manuals and navigate to page 19 and find procedure step number 2. Please follow along as I read aloud step 2 with you. If you need to pause to access your lab aids manual, please do so now and then restart the video. Step 2 says, to evaluate your hypotheses, use student sheet 2.1, modeling genes, to model the behavior of genes passed from parents to offspring. When you do this, make 3 assumptions. First, the blue and orange plastic discs represent the genes for the blue and orange tail colors, as you see Mr. Rancourt modeling now. Offspring then get copies of genes from their parents. Remember, offspring are just the children of any genetic reproduction. Each critter has the same number of genes.
Okay. Remember that a model is a representation of a system scientists use to help one understand and communicate how the system works. So this is our model. A model can also be a physical model, a drawing, a mathematical equation, a computer simulation, or any other way of representing a system that is useful for understanding and predicting phenomena.
And evidence suggests that bits of information called genes, and these are our genes, are present within cells and that copies are made and passed to the offspring. So at this time, let's go ahead and model our hypotheses in an effort to best determine which of our hypotheses best shows the behavior of genes passed from parents to offspring. Are you ready, Mr. Rancourt?
Yeah, let's do it.
Okay. In our first hypothesis, if you remember, we came up with 3, said that each critter pup got most of its tail color genes from the parent with a blue tail and only a little genetic information from the parent with the orange tail. So let's recall that each time, or let's recall the 3 assumptions. And the 3 assumptions are that, or one of the 3 is that offspring get copies of genes from their parents. So just as Sky and Poppy have 4 genes, their offspring must also have 4 genes.
Right.
And this particular model that Mr. Rancourt just showed us states that the critter pup gets most of its tail color genes from a parent with a blue tail and only a little genetic information from the parent with the orange tail. So do you think this model works, Mr. Rancourt?
Well, it doesn't work because it says in the 3rd generation that we have some critters with orange tails. And right now it looks like all we're going to get is blue tail because most are blue. Most genetic information is blue and only some is orange. Don't you think?
I agree. Let's look at our second hypothesis.
Take that off.
Our second hypothesis states that each critter pup got all of its tail color genes from the parent with the blue tail, and none came from the parent with the orange tail.
Well, I think that's worse because now, whereas before we had at least one genetic information that was orange, now we have all blue. So there is no way ever that the 3rd generation will ever have orange tails because all they're going to get is blue tail, right?
I agree.
Okay.
So let's look at hypothesis C. In hypothesis C, you stated that each critter pup got half of its tail color information from each parent, but the information from the blue-tailed parent overwhelms the information from the orange-tailed color parent.
Well, that makes sense because now we have half and half, and even if I have orange in here, the blue will be, what's the word we're using?
Overwhelmed.
Oh, yeah, overwhelmed. Overwhelmed over the orange.
I think you're right, Mr. Rancourt.
This seems a little more logical, I think.
I agree. So at this time, ladies and gentlemen, we're going to ask that you pause the video and that you proceed to your analysis questions.